dy dx minus 3y equals xy to the 4. Let's work out the substitution we need then. Everything's in the range in the correct order. Value of n here is 4, so it's 1 minus 4, which is y cubed, to the, y to the minus 3. So let's get dv dx now. Differentiating gives dv dx equals minus 3 y to the minus 4 times dy dx. And now we can move things around, so dy dx then will equal, the y to the 4 can come up to be with the dv dx, so to speak, because it's y to the 4 underneath, isn't it? This 3 can come down to be there, and we've got a minus, haven't we? So there's dy dx, and there's v. So substitution now gives, so dy dx, which is this, minus 3y is equal to x y to the 4. Divide by y to the 4 all the way through. So divide by y to the 4. See what we get now. We get minus 1/3 dv dx. Minus 3 divided by y to the 4 is 1 over y cubed, which is v. And that's x. Now times by 3 all the way through, minus 3. So that will give us just dv dx here, which is what we want. Times by minus 3 you get plus 9. V equals minus 3x, isn't it? There we go. Here's our P that we can circle. I'm call that P, and now here the integrating factor then equals e to the integral of 9 dx. There's P put in, so that's e to the 9x multiplied by this integrating factor then in the line above. So we get e to the 9x times dv dx plus 9 e to the 9x times v equals minus 3x e to the 9x. Okay, circle u and v. We can have an integration by parts on the right hand side, aren't we? There's u and there's v. So we can now write this as d by dx of uv. U times v. That's a 9. Is equal to minus 3 x e to the 9x. So integrating gives, the integral of the left is just simply e to the 9x times v, and the integral of the right minus 3 lots of the integral of x e to the 9x dx. That's an integration by parts, which we can do quite quickly. This can be v, this can be du. So let's do that then. E to the 9x. Now v is 1 over y cubed, so let's put that in here. And then we've got minus 3 lots of uv, so that's x e to the 9x over 9, isn't it? Is the u times the v, minus the integral of u, which is e to the 9x over 9, times the v dx, which is 1, so that's okay, dx, close brace. So what have we got then? E to the 9x times 1 over y cubed is equal to the minus 3. Work through the bracket, then expand the bracket. That'll be minus 1/3. So it's minus x e to the 9x over 3. So one of the 3's will cancel. Minus, and this is a 9 here, isn't it? So we're going to get 3, and that becomes a plus, and it will be e to the 9x over 9. There's already a 9 there, so that makes 81, plus a k at the end. There we are. Constant of integration. So let's now see what we've got then. So we've got all this. So let's try and tidy up. So we've got 1 over y cubed then. I'm dividing by e to the minus 9x all the way through. So here we get 1 over y cubed. This is simply minus x over 3. The one of the 3's will cancel to be 1 over 27, so there's a plus 1 over 27 there, isn't there, when we simplify that fraction. And we can write that as k e to the minus 9x, can't we, when we divide by e to the 9x with the k. Invert it then, so y cubed will equal 1 over all this stuff here. I'm going to write that term first. Then I'll put the plus 1 over 27 in. And then it's minus x over 3. And put it in a bracket. Because now we're going to take the cube root. So we're taking the cube root here, both sides. So y will equal, the cube root at the top is just 1. The cube root of the bottom thing, let's put it in. K e to the minus 9x plus 1 over 27 minus x over 3. Cube root of all of that. Okay then.